Okay, so in this video I'll be going over training module 5, which is to do with a water pump. So we're pumping water from a tank through a pipe system. There's a valve, globe valve, to control the flow, and there's something that corresponds to an internal diameter of 182mm orifice, and we're also going up an elevation of 10 meters. So to start off, we want to create our fluid sources and our fluid sinks. So we go to add fluid source, want it to be water, and this is 0.1 bar gauge pressure, so I'll call it 0.1 bar gauge water, and create a new fluid source. Do the same with the fluid sink here. So this is a 20 bar gauge sink, so I'll call it 20 bar gauge sink. You can create that fluid sink. Now we want to create the actual pipe system now. So we go to add a new line, and this comes up. We can use standard connection size. We'll be using DN200 schedule 40. I'll leave that to the north initial heading. This is our 0.1 bar gauge water source. I'm just going to elevate it by 1 meter, just so everything is above ground. So I'll double click on this to center it, and then we can move it off to the side just so we can see everything. Alright, so we want to define our pipe sections, pipe bends, orifice, valve, and pump. So to start off, I'm just going to leave this at default 1 meter because we can adjust it later. Same thing, I'll leave the default bends. And we want to create here our orifice. This has an internal diameter of 182 millimeters. Everything else is default values. And the valve here we can define as a globe valve. We can add the valve curve, but I'll leave that as default. Now we want to define our pump. The suction and the outlet both have the same values, so we'll leave that. And we can see here that we've given pump data for this pump. So you want to adjust the simulation to match that real life pump data. So we can see here, this should be 6 meters, just our pump curve, and I'll just put in all these values. And you can see as I do that, the graph below updates to match these values. The pump efficiency here, that's correct, 83, 4 and 43. Oh, I've obviously messed something up here. We can see from the curve it's this point here. Which one is it? These two. 140, that should be 210, and the efficiency at this point is 83. Alright, that looks a bit better. Okay. Alright, that all looks good. So now we can actually add it to our system. So I'm going to start off just a 1 meter pipe here, and then we can add in the pump. You can see here that this is pointing upwards, but if it's not, or if you ever want to rotate it to point another way, then if you right click on your pump, go edit, you can rotate around pipe by and specify the degrees there. But that's correct. So I'll just go up 1 meter before turning north. And this is where we have our pipe section that contributes to the 200 meter long length. And then I'll turn right, another pipe section, turn right again, and another long pipe section. We'll change that later. And I just realized I forgot to put in, we wanted our valve at the start to control the flow. So I'm going to add it in here, and then we can right click and cut, and I can paste it upstream of this, and you can see it'll insert it in there. And now I can add in the orifice, and we want to turn up, and this is where we have a pipe that contributes to our 10 meter elevation. And then turn south, and we can have our sink at the end there. That's a 20 bar gauge sink. Alright, so we've got all the basic components in place. Now we just need to sort of match this to the problem. I'll go back to that here. There's an elevation of 10 meters relative to the source. We've got a 1 meter elevation here, so I'll adjust this to 9 meters to make that a total of 10 meters elevation. Focus on this. Alright, there's the 10 meters elevation. And now we want to do the 200 meters of pipe. So we have 1 meter here, 9 meters there, so that's 10 meters total. If I adjust this to 2 meters, it just makes the maths a little bit nicer, because that way each of these need to be 200, take 10, 100, 95, 94 meters each. Alright, so I'll edit this to 94 meters long, and the same thing on the other side. So we now have 200 meters of pipe in total. And I can change the source here just to be the open top tank, and I'll make it 3 meter inside diameter. I'll leave that. Freeboard height above liquid 1 meter. Okay, there we go. Now we actually want to solve some of these questions. Well, sorry, answer some of these questions. The valve at the moment, the default is 50% open, but I'll just check that. Edit. Yep, that's 50% open, so I haven't changed it. Now, what is the pump power requirement at design conditions? If we go to the flow solver here, we can actually click on this to set the resolution along pipes. So I'm going to leave that to low because we've got very long pipes and it's not necessary. It'll take too long if we use a high resolution. We want to calculate the flow rate. So we solve for this. It doesn't take too long. We can find out we get 257 tons an hour. That's close to the design flow of 250 tons an hour, so I'm happy with that. And we need the pump power requirement. So if I right click on the pump here, where is it? There we go, and go to properties, we can see here that the motor is delivering 278 kilowatts. So the power requirement is 278 kilowatts. And what is the maximum water feed temperature that is acceptable before the pump begins to cavitate? To check whether the pump is cavitating, we want to go to the pump and we can have a look at its, we can have a look at the pump curve. If we go to edit, you can view the pump curve. And we can see here it's a good solution, there's no cavitation. It shows us our flow rate and the shaft work that's being performed. Alright, so we want to know the maximum water feed temperature that's acceptable before it cavitates. To that we can use basically trial and error. We edit our source here. We edit the fluid source, and through trial and error I've come up with 83 degrees centigrade. So I'm going to call this 83 and modify the fluid source to match this. And now, as before, we can solve it. And on our pump here, we can look at the pump curve through edit pump curve. There's no cavitation at 83 degrees. And if we do another fluid source here at 84 degrees, change each of these values and modify the current fluid source. Again, solving for it, we can look at the pump curve again, and we find that the pump is cavitating. So the maximum water temperature that's acceptable before it cavitates we find to be 83 degrees.